Okay, crazy ideas for the carousel. Clearly this thing, obviously it's moving in a circle like this, right? So we ought to be able to figure out the tangential velocity at any given point, right? So this is one thing, right? Not terribly exciting, but how fast are you going, right? 2 pi r divided by t. So t is the time to go around. And you could have either timed that when you're at Oaks Park, or you can actually get it off a video the same way I get it for the Ferris wheel, right? Okay. And we have the radius of this. That's on the website if you go to the carousel thing, right? So that's one thing, right? The second thing you can do is you can get the lateral acceleration, the centripetal acceleration, right? Which is 4 pi squared r over t squared. Now this is liable to be very small, and you're not going to be able to measure it with your accelerometer while you're on the ride. But there it is, and there's a chance that our lab quests could pick that up if you request that data. I'm not sure we have some in there. We'll maybe look here in a second, right? Okay, and then the other thing you can do is in this rotating frame of reference, you can actually witness the Coriolis effect, right? If you have two riders, a person here and a person twice as far out, right? Their tangential velocity, this person's tangential velocity is half of what that person's is, right? And so the weird thing is, and I've gotten permission to do this, if you take a paper wad and you throw it radially, right? If you throw it straight out like that, you're throwing to a part of the frame of reference that's moving faster forward, right? Because the whole thing is rotating this way, right? And so the paper wad will appear to curve behind that person. And likewise, if this person throws a paper wad like that, it will appear to curve in advance of them, right? Like that, because you're throwing it from a part where you're moving faster this way to a part where you're moving slower. Now this is just an illusion. It's not really curving. Somebody from above would just see the ball go in a straight line, you know. So anyway, you could film that. You could actually take your little camera on your phone or something like that and actually film that. It gives the ball a wicked curve when you do that. Those are just ideas on the carousel. Be nice to the carousel. It's old and famous. Let's look at the website. Whoops. Okay, let's look at the website. If you go to Oaks Park and you go look at the carousel, okay, we know the diameter of this thing is 17.7, and if we go in there, there's some lateral accelerations on there. So let's take a look at what those are. I'm doing a control click, save link as. I'm going to put it in my Oaks Park data folder, and I can just open that up. And there's not a whole lot going on, right? But let's mess with this thing, right? Go options. Whoops, graph options. Let's turn off all these guys. Okay. That makes it a little bit nicer. And then the question is, can we look in there? This is set ridiculously high. We're going to be looking at a very small thing. So let's make this maybe 5 meters per second. And this guy maybe -5. And it looks suspiciously like there is actually a lateral acceleration here that's, around 1 meter per second squared or so, right? You could do something like grab a chunk of this, right, and just give me statistics. Analyze statistics, right? The average is about a ½ a meter per second squared. So then the question is, what's your 4 pi squared r over t squared? Is that about what it is? Okay. So, hey, go for it.